Hi everyone, I'm Hanghang from Complutense University of Madrid. Today I want to share my work with you here. My topic is activation of the alpha protein response and fibrosis drives cholangiocellular injury and an experimental model of fibropolycystic liver disease. Fibropolycystic liver disease is characterized by hyperproliferation of the biliary epithelium cells combined with the formation of multiple dilated cysts filled with fluid. A progressive process associated with UPR. The junk plays an important role in converting extracellular stimuli into a wide range of cellular response. The age of junk knockout mice presents bile-duct hyperplasia mimicking PLD. Our aim is to explore the mechanism of cyst formation and UPR activation of junk knockout mice during progression of the liver disease. We use three models of animals. Mice with junk theta helper and junk flox were sacrificed at different time points. And two, both 8 weeks mice of two groups were received tunicomycin and sacrificed 24 hours later. Last cell as 10 mice was used for 24 weeks to 8 weeks old mice. We sacrificed both groups of mice at different time points. Fibrillary collagen networks were identified from aging junk theta helper mice. From the Western blot, alpha spooms all expressed in the junk theta helper mice, and it increased in aging junk theta helper mice. We examined inflammatory cells. All were increased in junk theta helper aging mice from 32 weeks. Hepatomegaly was observed from 52 weeks old mice, where the increased liver body weight ratio from 32 weeks, 100% of junk theta helper exhibited cysts across the hepatic parenchyma. ALT and LDH level, the quantification of turnout, and Ki67 were increased in junk theta helper mice with age. Here, secreting protein elevates. Also, the positive air of GS staining and PA staining were observed in junk theta helper mice. The YAP1, JAK1, and HAY1 were upregulated. The UPR effector BIP and CHOP were always expressed in 32 weeks old junk theta helper mice, which associated with increased SBP1. After DN treatment, we also seen the elevation of UPR effector in junk theta helper liver. After TAA treatment, it didn't trigger the UPR effector except for CHOP and junk theta helper mice. During zero stress staining, junk flox liver show bridging fibrosis, and junk theta helper liver display polybiliary-like fibrosis. While typical marker of oval cells and biliary epitheliums were prominent and untreated junk theta helper liver, but compared with junk flox mice, they were strongly overexpressed after TAA. My conclusions: 1. Fibropolycystic disease and aging junk theta helper mice is characterized by extracellular matrix deposition and inflammation. 2. Lack of junk promote hepatomegaly and liver damage. 3. TM promote the activation of the UPR trigger and increase liver injury and junk theta helper mice. In addition, markers of cholangiocarcinogenesis was found in junk theta helper liver after TAA. 5. ER stress and fibrosis with cholangiocellular injury and cell death in junk theta helper mice, which are sensitive to CCA development. 6. The junk theta helper model can be relevant experimental tool for the study of fibropolycystic liver disease. Okay, this is what I want to share with you. That's all. Ciao.